Hello students, welcome to Learner's Planet, Theory Problem Solving Session 3 of Carbon and its Compounds. In our previous session we discussed questions, we actually solved questions related to IUPAC nomenclature. In this session also I'll be dealing with the questions related to same, that is the IUPAC nomenclature. Now let's start with our first question, students. It is write the structural formulae of organic compounds whose IUPAC names are. Okay, so what are the IUPAC names here, students? These are, first is 3-ethyl 2-methyl pentane. So what I'll do is I'll write here. The name was A. It was 3-ethyl 2-methyl pentane. Now in my theory session I told you that the one which comes alphabetically first should get the least number. But here it is just the name which is provided to you and you are supposed to write the structure as it is. Okay, so please don't try to rectify the name. Now let's start with it. These are what? This is a substituent. This is again a substituent. Pent, it's what? It's the root word. And ane is what? The type of bond present between the carbon atoms. So now let's write the structure. First of all, what I need to do is I need to write how many carbon atoms? 5. So it is 1, 2, 3, 4 and 5. Now what? Let's count. This is 1, 2, 3, 4 and 5. Yeah, it is what? It is 3-ethyl, third position, and 2-methyl. Its correct name should have been 2-ethyl 3-methyl, but you have to draw the structure as it is given. So it is 3-ethyl. What is ethyl? What is the formula of ethyl? It is C2H5. And what is the formula of methyl, students? It is CH3. So it would be C2H5 here and CH3 here. Okay, and rest of the position will be occupied by what? Will be occupied by hydrogen. Okay, so I can write the formula or the structure as CH3, CH2, sorry, it should be CH3, okay? So there would be CH3, there would be C2H5, then there would be CH2 and CH3, right? Now in these bonds, when you are drawing the structure, you need to put all the hydrogens. Okay, I'm not putting because it will look cluttered here. So this will be your answer, this, okay? Let's move to our next question. It was 3,4,8 trimethyl decane. So its B is what? 3, 4, 8 trimethyl decane. Okay. So what's the root word here, students? It is dec. It means how many carbon atoms are there? There are 10 carbon atoms. Okay, and let's start counting from either the LHS or RHS. It is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now 3, 4, 8 at the third position, at the fourth position and at the eighth position. What all we are having? We are having methyl groups. What is the formula of methyl? It is CH3. So what I'll do here? I'll put a CH3 here. I'll put CH3 here. And I'll put CH3 here. So what it is? 3,4,8 trimethyldecanes. And the rest of the bonds will be occupied by whom? By hydrogen. Okay. Now let's move to our question part. So if you want to write the complete structure, please put hydrogens here. Don't leave the spaces or the bonds empty. Okay. So this will be your hydrogen. Now let's move to the next question. It is again write the structural formulae of organic compounds whose IUPAC names are given. Your first is 3,3, it should be dimethyl. So I'll put a di here, pentane. And next is 2,5-dimethylhexane. Now let's move again. This is what? Question number 2A. This is 3,3-dimethylpentane. So what is the root word here, students? It is pent. It means how many carbon atoms? 5. So it would be 1, 2, 3, 4 and 5. Ane. What type of bond is there? Single. Okay. Now let's start counting. 1, 2, 3, 4 and 5. So I'll draw a structure here. This is 1, 2, 3, 4 and 5. That is 1, 2, 3, 4, 5. Now I'll put bonds here. Now there is 3,3-dimethyl. It means here there is a methyl group, CH3. This is again a CH3. Okay. So this is 3,3-dimethylpentane. And the rest of the bonds will be formed with the hydrogen atom. So this is your complete structure. Okay. Now moving to the next part, it is what? 2,5-dimethylhexane. I'll draw the structure here only. What is the root word here, students? It is hex. How many carbon atoms? 6. So it would be 1, 2, 3, 4, 5, 6. Now let's start counting. 1, 2, 3, 4, 5 and 6. Now let's draw the bonds here so that we can put up the atoms or the molecules. Okay. So these are your bonds. Then we will put up the atoms here, or the molecules here. Now it is what? 2,5-dimethyl. So that is at the second position there is a methyl group, that is CH3. At the fifth position also there is a methyl group, that is CH3. And rest of the positions there are hydrogen atoms. Right? So this is what this is: 2,5-dimethyl hexane. Okay? Now let's take up our next question. Yeah, this is name the classes of organic compounds represented by the following formulae. Now look here students, in the very first one, that is in the A, what is the thing here? It is CH3OH. So which group is present here students? The group is, which group is there? It is hydroxy, right? And hydroxy group is present in alcohols. Okay, so what is this compound? This is an alcohol. Now how many carbon atoms are there? There is only one carbon atom. And what will be its name? It would be methanol. That is methane. E is replaced by all, right? So this is an alcohol. Now the second question, which group is there? This is what? This is a ketone group. I told you what it is, that is C double bond O R and R. Okay? So which group is there? This is a ketone or a carbonyl group, right? So this is a carbonyl, C, right? And this is C double bond O. Okay? So this is what? This is a carbonyl group. And what is this compound? This compound is propanone, or what? This compound is propanone or acetone. Okay? Now let's take up our next question here, students. It is, first is, write the name and formula of the functional group present in the compound CH3COOH. So you're the first one. So what is the name of the compound? It is what, students? CH3COOH. How many carbon atoms are there? 1 and 2 carbon atoms. What will be the root word here? It would be eth. What type of bonds are present between the carbon atoms? Single. So it should be ane. Now which group is present here? It is what? It is carboxyl. Right? So what it will form? It will form acid. How we frame the name of an acid? This E is replaced by oic acid. Okay? So what would be its name? its name would be ethanoic acid. Right? What is its common name? It is acetic acid. Okay? So this is the way how we do. Now our next question here is, how are the molecules of aldehydes and ketones structurally different? So in aldehydes and ketones, the functional group is what? It is carbonyl. That is, it is C double bond O. Okay? But in case of aldehydes, it is what? It is R, that is an alkyl group. There is a hydrogen and there is double bond O. But in case of ketones, there is C double bond O, there is one R, that is an alkyl group, and another alkyl group. Right? So this is your aldehyde and this is your ketone. Got it? Now let's move to our next question. Now students, here in the place of alkyl group, you can place either methyl or ethyl or propyl. Any alkyl group can be there. And what is an alkyl? An alkane from which one of the hydrogen has been replaced or removed. Now the question is, pick out a set of homologues. What are homologues? These are arranged in a series and between two homologues there is a difference of CH2. Okay, so between two homologues there is a difference of CH2. Now from these molecules we need to identify C2H6. What is it? Is it an alkane or alkene or alkyne? Let's work out for its general formula. This is C2H2N, that is 2 into 2 plus 2. So it is coming out to be C2H6. So this is what? This is an alkane. Okay. Our next is C2H4. What is the general formula of it? C2H 2 multiplied by 2. That is C2H4. And this is an what? This is an alkene. The general formula of alkane is CnH2n plus 2. So CnH2n plus 2. The general formula of alkene is CnH2n. And next is C2H2. What is the general formula here? C2H2 into 2 minus 2. What are we getting? C2H2. And this is what, children, students? This is alkyne. And what is the general formula? CnH2n minus 2. Okay? Now, all the three belong to the different homologous series. Now let's take up the next, that is C2H5. So it is C2, this is an alkyne. Okay. So this is C2H2 into 2 plus 1. So this is C2H5. What is this? This is alkyne. Are there any homologues here? There are no homologues here. Had it been one more molecule like C3H8, so which of the two would have been the homologues? C2H6 and C3H8. Okay, so you can get questions like this. Now let's take up our next question here. It is again pick out the homologues. Now let's find out. C2H2 is an alkyne. C3H4 is what? C3H2 into 3 minus 2. That is C3H4. This is also an alkyne. C4H6. This is what? C4H4 into 2 minus 2. So that is C4H6. This is also what? An alkyne. Okay, so all these are what? These are all homologues. The difference between C2H2 and C3H4 is of CH2. The difference between C3H4 and C4H6 is again CH2. What about the next student? C4H10. It is what? C4H4 into 2 plus 2. So it is what? C4H10. It is what? Alkane. So this is not the homologue. Okay? I hope you can solve such type of questions. The next question is, the molecular formulae of the consecutive members of homologous series are C6H14 and C7H16. Okay, so this is C7H16. Write the molecular formulae of the members having 9 and 11 carbon atoms. So this is which series, students? Whether this is a series of alkane or alkene or alkyne, we need to work out that first. So now let's try to solve this question, that is C6H14. So this is H14. So it would be C6H6 multiplied by 2 plus 2. So its general formula would be CnH2n plus 2. Okay? Now, so this is what? This is the homologous series of alkanes. So what will be the formula of the compound with 9 carbon atoms? So that is C9, and what would be the number of H? How we will find out? C9H9 multiplied by 2 plus 2. So what we will get is C9H20. Okay, and the other one is 11 carbon atoms. So C11, H would be 11 multiplied by 2 plus 2. So this would be equal to C11H24. Okay. So in between them, what is there? There is C8 also. I'm telling you, it's not asked in the question. So it would be what? C8H18 also. Okay. And there is C10 also. So there is C10H22. So you remember, students, that between the two members or between the two homologues, there is a difference of CH2. Okay? Now let's take up our next question here. It is, which two of the following compounds could belong to the same homologous series? Okay? Now let's first crack down what are the compounds. C2H6O2. So how many oxygen atoms are here? There are two oxygen atoms. It means in which type of compounds two oxygen atoms are there? In carboxylic acids. So C2H6O2 is what? Is a carboxylic acid. Let's write down its formula. That is CH3COOH. Is it a carboxylic acid? Are the number of hydrogens matching? No. So this is not a carboxylic acid. Let's try out for an ester. CH3COOCH3. So is it an ester, students? No. So what it is? Now I'll have to make a correction here that it should be C2H4. Okay, you'll not get such type of questions. The mistake has been done in this question. Now it is an acid. Right? So this is the way we find out the formulae. Now our next question is, our next compound is C2H6O. C2H6O. So there is a single oxygen atom. Now students, it can be an alcohol or an aldehyde or a ketone. So let's start writing it. It could be C2H5OH. Right? Had it been an aldehyde, so then its formula would have been C3CHO. Are the hydrogen atoms matching? No. So this is not an aldehyde. Had it been a ketone, it would have been CH3, C double bond O and CH3. So this is also wrong. So what is it? It is an alcohol. Now our next compound is C2H6 and this is an alkane. I hope you know this now. Our next compound is CH4O. Now what it is, students? It is CH3OH. Okay? Had it been CH3OH, so this is what? This is an alcohol again. So which two compounds are homologues here? Belong to the same homologous series? This is ethyl alcohol. That is this and this. Okay? Had there been one more option like CH2O2, what would have been this? This would have been HCOOH, that is formic acid, right? Then what would have been the homologues here? This and this. So this is how we find out the members of the homologous series. Now I'll conclude this lecture, students, and we will be meeting in our next session and we will discuss or we'll solve questions related to what we are going to solve now. We will solve the questions related to ethanol and carboxylic acids. So students, we'll be meeting our next session and I hope you'll solve many more structures, you'll draw many more structures and also you'll name them according to their IUPAC nomenclature rules. Okay? Thank you.